Hello, and welcome to Outer Monologues, the show where I talk. I'm Castor Köhler, and today I will be talking about what you can actually learn from mathematics. So, a quick disclaimer as always, these are my personal thoughts on this subject. I don't do any specific research beforehand, and this is simply the inner monologue going on in my head, but, spoken out loud. So, if you want to correct me on some factual mistakes that I've done, please hit me up with a message on, for example, Instagram, Outer Monologues Podcast, or an email at the address outermonologuespodcast@gmail.com. But on to the episode now. Mathematics, I think, is probably the most hated subject in school, if you think of an average. If you ask a youth or a child that still goes to school what subject in school they dislike the most, I think I'm just guessing that you would find that math is the most prominent of these subjects. I don't really know why. I think it might be because it's kind of a difficult subject and you kind of need to think in a certain way. And I think also a lot of people that are struggling even a bit with mathematics it's a lack of motivation that they have. And the lack of motivation is backed by the fact that there is the argument that there are calculators everywhere now in the world. And, well, why do I need to count 1 plus 1 when I can just put it into the calculator and it will do the work for me? But I think this misses what math actually teaches you. It only focuses on these rules and the mechanical parts of counting, and the mechanical parts of math. But the most important part of math, in my opinion at least, is the problem solving that it teaches you, and the basically, in a way, a pattern matching as well. And this is kind of what I wanted to talk about this subject, because I feel like math is an underrated subject in general, and we can learn so much from it, but it has gotten a bad reputation and it kind of misses in education, misses in a lot of cases what it actually is about, or at least conveying the information to the students. But I won't talk about this any further right now. Let's get into the first chapter of today. So, chapter 1, how education gets it wrong. And as I just said, I think math gets a lot of hate in school, and I think it's totally fine that different subjects are liked less or more than others. It's just the natural way of things, but I think math gets an unusual amount of dislike, and I'm kind of curious. I've thought a lot about why this is. Is it just because math is kind of a like this polar subject in a way, where you either like it a lot or then you don't like it, and when you dislike it, you really dislike it. You're not like equal or like just lukewarm on the subject. You actually hate it. But what I find kind of problematic is that it has become very accepted and very normal to say that you don't like math. If you compare to other subjects in school, if you say that you really hate, let's say, physical education, so you really hate those classes, your parents and other people, or usually grown-ups, will tell you that, but it's so good for you, you need to move. And I think the same goes for a lot of other subjects, but the kickback or the pushback when someone says that they hate math is generally, I think, a lot less, and it's kind of accepted not to like it. And that's kind of against my philosophy, at least, that there should be this one subject that is incredibly important and almost shows up in every line of work, but it's still a subject in school that is hated and is okay to be hated. But I don't think the attitude, the changing of the attitude will happen from a point where you just need to tell people that, oh, you should like math. No, it needs to come from the education perspective of things. The people teaching you, so the teachers, need to kind of maybe actually convey what math is about and try to more focus on what you can actually learn and what you will need math for later in life. So right now I feel like the thing that education focuses on in math is basically the very boring, the boring part of math, the rules of mathematics. So you learn basically that 1 + 1 is 2, and you learn that 1 × 1 is 1, and maybe that 2 squared is 4, and you learn these really mechanical things, the basic rules of how math works, and of course that's cool in a way. For me that likes math, I can find this cool because I think this is like the rules of the world. People say that would mathematics exist if we didn't invent it, and I absolutely think that of course it exists, because 1 + 1 is still 2. If you take an object and you take another object and you add them into a basket or something, then you have 2 objects. Whether you put a name on it, we just put the name 1 and 2 for these amounts, but the fundamental, the fact will still remain. And that's the fun thing about math. It will be there whether we invent it or not. But that's kind of a thing that is fascinating and fun for me because I like math, but it might not be a thing that is commonly found fun. But these parts, I think, I think they shouldn't be focused on that much, because if you compare them, for example, to languages or to learning languages, this is, I would say, the same as learning the grammar for a language. And linguists and people that love learning languages might find grammar fascinating and very fun. But most of the people, when they want to learn a language or when they have to learn via school, then it is not because they want to learn the grammar, it's because they want to speak the language. So I think the rules of math is basically the same as the grammar for a language. It's the boring part that you need to know, but that isn't maybe the end goal of the subject. So what is the goal or the true learning, the true thing you want to learn from math? What is the end goal? I think this is problem solving. Because okay, I maybe want to explain a bit what I mean by problem solving. It's a way that you get a system in your mind and you learn to think of different problems. So you encounter these problems in real life or in your work or wherever, and it basically gives you a system of how you approach these problems and basically how you can approach them and actually, even though it's a large problem, you might get through it actually, and you don't get overwhelmed by it. And it's also a way to prove that maybe a large problem is the way it is, or you might disprove a theory as well. So you might prove that something isn't the way it is, with a series of different arguments that are. You can check each one of those arguments on a logical line and say that, okay, these all seem to match up and maybe it isn't the way we thought, or maybe you can prove very rigorously that a theory is correct because here are the line of arguments. And if you can find a fault in those arguments, then the theory isn't true. But if they are if you don't find any faults in there, then it must be true. So this is basically what I think is the most important part of math. And these like learning goals of problem solving and pattern matching and so forth, they are usually more prominent in more advanced math. So for example, in the first couple of grades, you won't go through basically problem solving. You will need to go through the basics of math, because you need to build up your toolkit to actually be able to learn what's the end goal. But there is also a lot of simple math that can teach you how to solve problems as well. But the problem is that education doesn't really bring these up, and they don't really bring forth the places where you can learn and where you can use the math and the way of thinking that you learn. And I think this is very well exemplified if you think about math questions in tests or just in exercises that you do. I think there's a like meme / stereotype that is very common, that there's always someone buying like 51 melons or something. And they're always, I think, a bit weird and exaggerated, these math examples, because you kind of want to tie them into the real world, and but still have some sort of like large numbers. And I really don't see why you can't have it completely in the real world. Why do you need to have someone buying 31 watermelons? And then, let's say, I wrote down an example just to make this more clearer. So you could have the math question now that you have someone buying 31 watermelons, then that person gives 3 of these watermelons away to a friend, and at the end of the day they come home and then they split half of the melons with their spouse or roommate or something. And now you have the question, how many watermelons does this person have now? So that might be a question. So you have 31 minus 3, and then that result by 2, and then you get the final result. But how could you actually... This is an absurd example, because someone buying 31 watermelons and doing these things are simply not realistic. So you could, for example, say that, okay, this person instead has 31 euros or dollars or whatever currency you want to have in your country. Then this person goes out and maybe buys a cup of coffee for 3 euros. And then comes home and puts half of the remaining money in this person's piggy bank and chooses to keep the other half for spending. And the question is now, how much money does the person have for spending? Or you can also ask, how much money does the person have in its piggy bank? And this is a lot more, this is a kind of realistic example. Someone has money, buys something, and then chooses to save half of the remaining. And this, I think you could, almost every sort of math question, especially when it's a bit more basic math even, it's very easy to come up with these examples. Of course, when it comes to like plus, minus, multiplication, division, this is very, very easy because you have these examples. You can always do them with money and someone spending it and splitting it with friends. But there is always, if you go into a bit more advanced examples, this is usually also at a bit older age. So you can start bringing in different examples from industries and professions where you would actually use these methods. And you don't need to go into the details of the actual profession or the use case, but you can basically try to take examples from them. And here is maybe as an example, when you learn about percentages. I know it's not the most advanced math thing to learn about, but it's still at a bit older age and a bit later stage than just the normal multiplication and addition rules. So here you could, for example, very easily bring up examples from economics, for example. And because in economics, there's a lot of things that are based around percentages. And for example, you have the interest on loans, or let's say a stock market's value that goes up by a certain percentage. So you could easily have examples based around that maybe a person buys, let's say, 50 GameStop stocks for $50, and then the GameStop stock goes up by 427%. And then you ask, how much is the GameStop? And then this person, you might say that this person now sells the stocks, and how much money does this person now have? And this is kind of a very practical and very a real life example of how you would actually use percentages, because you usually don't use them for really everyday life, but you kind of use them for like semi everyday life matters, such as money in a lot of cases, and economics. And I think you could always, in almost every case when it comes to math, you could take these real world examples and tie them and show what you can actually use math for. And I really want teachers and educators in general to emphasize how you actually get from the problem to the math and then to the solution. So for example, you will have your problem, and not only give like straight away the problem that you need to find the solution for this equation or something, but rather have a problem where the students first need to figure out what math formulas and what math rules they can apply to the problem. So this is a very important part to learn. That you see a problem in real life and you kind of know where you want to end up, but you don't really have the path yet. And then you look through your toolkit of different things that you have. It might not be math. It might be, if you talk about health or something, it might be what you know about that subject. But you look through your toolkit and kind of think through everything, and then you find something that I might be able to use this information and this thing that I know to reach at least a next stage that brings me in the correct direction. And then you do this multiple times, and then you arrive at a solution, and then you can see like, to solve this problem, I need to do this, and then this, and then this, and then this, and then I'll arrive at a solution at where I wanted to end up. So this is what I mean by problem solving, and that brings us into the next chapter. Okay, so chapter 2, problem solving. So this is what I actually think math is good for. In general, you might need more advanced math in your life for your profession, or very, very specific math. But if you think about maybe an earlier stage of education, then everyone will need so different parts of math. A mathematician might need a certain kind of math, the thing that he or she decides to specialize in, while maybe a person going into economics might need something completely different, and someone going into tech things might need another set of things. So it's the constant problem of like early education, that everyone needs very different sets of skills from a certain subject. But what you can always learn is problem solving, because this isn't something that will even maybe apply to your work life. It enhances your just personal life already, and that's I think a superb thing, that you can find a subject that you can use and learn in school that will not only increase your professional capabilities, but also improve your everyday life. And basically, problem solving is the fact that you can tackle a problem. You can see a problem that you need to fix, and then you can split it into smaller pieces, and basically formulate the problem in the language of the science or of your choice, or the subject of your choice. So if it's something about you want to lose weight, you might not use math, because math is kind of useless in a way when it comes to counting how you should lose weight. But now you go to your other toolkit, you go to your health related toolkit, and you see that, okay, to lose weight, I might need to exercise more. I might need to eat more healthy. And you kind of go into these. So you split the larger problem into smaller sub-problems, and then you basically solve these smaller pieces one by one. And it might be that they follow in a sequential manner. So you solve one problem, and then from that problem you don't get a straightaway part solution, but you get another problem, but it's still working towards the end goal. So you basically get another problem that you solve again, and then you slowly work towards the end goal. It might also be that they split into like parallel pieces. So you have one piece that you can completely solve, and you arrive at a part solution, and then you have multiple of those pieces, and when you've solved all of these multiple pieces, then you have the entire solution. So they come in different forms, but they still boil down to the same principle, where you have these smaller pieces of the problem, and you can solve them individually. You might not be able to solve the entire problem straight away, but in pieces you can. And then when you've completed all the pieces and solved all of those problems, then the bigger problem is solved as well. And this way of thinking and this way of problem solving is so good, just because partly you can tackle big problems. So you can have very abstract big problems, and you learn how to boil them down into smaller pieces and then solve these. But also the fact that you can show your thought process all the way through the problem solving. So this is very very important in the professional life, especially if you're gonna research anything or try to prove something, because you need to show your process. Then you need to explain it in a way where other people can replicate your thoughts and then see if they actually match and if it actually works. That's how science works. But it's also just in other parts you can double check yourself if it's something just maybe not that serious, but you can double check your thought process that is this correct, and just you can convince other people maybe that they're in the wrong about some factual subject, because you can show that, okay, so if this matches, and then this matches, and then it's very easy also to point out, to see for the other person, if you're trying to explain it like that, they can see like, okay, this part piece here I don't really agree with, or it doesn't actually, it's not true. So basically the entire thing falls on that, or it might just be that small piece that falls on that. But it gives you a system with which you can actually fix things and think things through. And I think it's just so important. And especially in our modern world, where you can, of course, in some ways you can trust, if you see something physically happen, you can maybe trust that it's true. But even that isn't set nowadays, because you can fake so much and you can manipulate so much. So especially if you see digital content or something, so you see a video or a photo or something, these can all be manipulated so incredibly much and look so real still that you can't really trust these. And even if you see physical things happen, they're so let's say magical people, especially magicians, can show you this, that you shouldn't always trust what you see with your eyes, because there's sleight of hand, and there's so much like manipulation of where your focus is and what you can see. And this just shows that it's very important to have these thought processes and a way of showing that your theory or your thought or your way of working or how you want to lead your project at work and how you want to become a politician or I don't know, whatever, that it's a good way of thinking and that this should work. So basically, that's all I had to say about this subject. I think the true joy and value of math isn't learning to count, but rather to solve problems. And I think actually that most subjects in school and education and just in the world actually maybe suffer to different degrees of this phenomenon. That education and school maybe focuses on one thing, but the true value of the subject is somewhere completely different. And it might be very difficult to find out what this underlying important skill is without delving deeper into the subject. And to delve deeper into the subject, you either need to be extremely just hard at work, even if you don't like the subject, or you might need to talk to someone else that explains it, or I don't know. It's very difficult to find the motivation to do that if you're not interested in it. And basically, I would like to do this series. As you've listened to this point of the episode, I want to turn this into a series with also multiple episodes of different subjects and this phenomenon. And I can't really do this by myself because I only have insight into a few different subjects. So I would like to bring in guest hosts with expertises in different subjects and thoughts on their own subject that might not be apparent to people not specialized in their field. So this is where I ask you if you are interested in being a guest host here and doing one of these episodes, please be in contact with me. As I said earlier, you can be on Instagram at Outer Monologues Podcast or by email outermonologuespodcast@gmail.com, or also be in contact with me. Write in my Instagram comments or privately, whatever. If you have a specific subject that you just want to hear about, this kind of discussion, because I think it's fascinating and I would love to hear from you as well. So that's all for today's episode, actually. Thank you for listening. Today we talked about what you can actually learn from mathematics. Music in today's episode was brought to you by Nuari Hector and Max Malmberg. And I'm Castor Köhler, and I'm out.
Nothing is easy when you're wetter than the sheets. I pay the price for living faster than I may. Lord have mercy on this wondrous day. Come on, lay down your head now and try to go to sleep. 'Cause the sounds of tomorrow, they will turn up the heat. Hold up your head now and stay on your feet. You will feel better once you wash those sheets.